Yeah. Have you guys installed your SolidWorks? Like all of you. I can't hear you if you are speaking. So can you guys see my screen? You guys are not responding again. You need to start. So it's only Abubakar. Onyenye and then Musimulua. Okay, anyway, so let's just start. Maybe they're actually busy currently. So now, today's session will actually be on the theoretical parts of CAD because of I'm assuming that you guys don't know anything in CAD. So that is how I see it. I'm assuming that you guys don't know anything in CAD. So I already shared my screen. Okay, coming. Okay, so good evening, guys. So good evening, good morning. I don't know whether there are abroad students here, but anyways, so we're going to be starting CAD today, and we're going to start with the introduction to CAD. So as you all know, CAD is computer-aided design. So before we touch anything SolidWorks or the software parts, I want to make sure you guys understand the theory parts because of you can't just start clicking buttons or interfaces without understanding what you are doing. So and if you don't understand the buttons that you are clicking, interface that you are navigating, your models will easily crash. So by the end of the session, you're going to understand how the 3D models are structured, the plane, what are planes, how you view objects, and design thinking. What separates a good CAD designer from someone who draws line. So if you guys are hearing me or can't hear me, you can just use the chat section. So what is CAD? Move it up a little. So CAD is just a software that's used to modify and edit 2D drawings and 3D physical objects before they are even manufactured. So what I want you guys to focus on is that actually before they are manufactured or before they are built. So in those days, the engineers will sit down with pencils, ruler, and drawing board and manually draft every single dimensions of each part. And if something changed, you have to erase and redraw. So and it was actually slow and it causes error. So CAD actually replaces all that. When you design on your computer, you test it virtually, you make changes in seconds, and if everything is okay and all right, you can start your manufacturing or 3D printing. That actually saves money and time and materials. So as you can see, where CAD is used in embedded systems, CAD is used to design and visualize products, it's used in architecture, automotives, and floor plans. So based on this training, you might be wondering you can actually use this card for to visualize your final product. And for now, currently now the startup I'm working with before when they want to pitch their products to for events or to investors, they present the 3D model of their products. Yes, that actually helps investors, help in negotiating with investors, and help in winning more points for competitions. So moving on to 2D and 3D card. So actually there's 2D and there's 3D, and we are going to be using SolidWorks. SolidWorks has the 2D, like it has a 2D version and it has a 3D version. So 2D is the flat surface. That's the flat surface of the lines. You're working with just length and width, no depth, no volume. Yes, let me put it like that. So you can see that 2D as a blueprint. You mostly see things like you mostly see 2Ds of construction sites or floor plans or a building. So there are tools like AutoCAD and Library Card. But for this training, I'm going to be using SolidWorks. So the 3D is like a third dimension. It's like a step further. You understand? A step further. So you model the height, the width, the depth, the volume, everything has mass volume. You can simulate how it will react to forces and also calculate its weight. You can check if it fits inside your assembly. That's if you are designing a a product that has different parts that joins together. That's actually what those that use SolidWorks do. Simulate, design, test run things. You can check the mass, the volume, and stress analysis. So, okay, I would like you guys to actually have your SolidWorks open because of as we're moving on, I will we'll be doing some like this. Like I said, it's theory, but at the same time, the theory also involves you opening your SolidWorks tools to be able to navigate and understand what I'm talking about easily. So most not even most all engineering firms actually work 3D, 2D and 2D drawings, yes. But they actually generated from 3D models, not actually drawn from scratch. So on that thing, I would like you guys to understand and learn is the 3D coordinate system. The 3D coordinate system. So the 3D coordinate system is the mechanics of how a 3D model exists in space. So every model in CAD lives inside a coordinate system, such as the three axes of X, Y, and Z plane. So the X plane or the X axis actually goes from left and right. It controls the width, how wide your object is. That's how the X axis fits into CAD. The y-axis also goes forward and backward, and the z-axis controls the height. So there's no need to cram all these things. I want you guys to just know it. You will understand it better when you start the actual 3D modeling. So all these three axes, they actually meet at a point. If you guys can see it, this point over here, they actually meet at a point, and that point is actually a coordinate of zero. That's, you can see the coordinate of 0, 0, 0. So this zero is actually the x-axis, as x, y, and z, they meet at zero at a point. So if I was to explain this x-axis to you again, you can see like the x-axis is like the wall in front of you. Let me just give you an example. Just imagine a wall in front of you. So facing it is actually, also the left and right is how you visualize the y-axis. I'm sure you guys can actually see my screen. Left, the y-axis. Why, how far forward or backward you move is the z-axis. The center is where everything meets. That's the point. As I said, the origin. So you guys will have to also understand reference planes. As I said, these are things that you not have to cram them, but during the course of modeling, you understand it better. These are not really things that are hard. So to actually those that have not touched CAD before, these are not hard. You have to just know them theoretically. So planes are actually the most important concept in CAD. A plane is like a flat, invisible surface that exists inside your CAD space. So if you actually have your SolidWorks open, there's a blank space there. Yes. So the plane, there's a front plane, there's a top plane, and there's right plane. So they actually exist invisibly inside your CAD space. The front plane is actually spans across the x and z axis. So it's like it's the face of what you're looking at directly when you look straight at an object. So normally that's actually where you draw your first sketch. Yes, that's actually where you draw your first sketch. Your first sketch. The front plane is actually how you can call it the face of your design. That's how I see the front plane. So why the top plane? The top plane is like um, a a top view. Yeah, yeah, the top view of an object while looking from it from while looking at the object from above. Yes. So just imagine you have a box in your hand now, looking at that box from the top view, looking down on the box from the top. So that top is the top plane. The right plane is like a the right plane consists of the y and z plane. I don't know. I'll share the slides to you guys later. But you guys can focus on this. The right plane is consists of the y and z plane. It's like a side view. It is good for side profiling. It's also good for to view features from a side point of view. You doesn't if you model a phone casing now, and you want to view it from a side, or from a point of view, that's actually where the right plane comes in. You can also create custom planes. Like you can create a custom planes. It can be at a point or at a vertex. You can create custom planes at a point or at a vertex. So now, um let's also talk about how you actually view your 3D models. So if you have a 3D object open in your CAD file, you can rotate it and view it as you like. But we have to also know that there are views and navigations in SolidWorks or in your CAD file. So the front view now is how is looking straight at the face of the object. That's like the starting point. While the top view, you are looking down on the you are looking down from above, showing the length and the width of the object. The right view is also looking from the side, showing the height and the depth of the object. Also, we have isometric view. Is the 3D perspective, looking at it from it's like looking at the model from an angle where you can see everything. You can see the front, top, and the right view. It actually gives you a general an overview of what you're modeling and what it looks like. This is actually what you're using mostly to view your models from an angle or from a point. So now this is actually the basics of CAD, of when creating an object or a model in SolidWorks. You choose a plane as I explained earlier. You already know what a plane is. You create a sketch on that plane, you apply a feature on it, and that's how you repeat it. You just keep doing the same thing. So for example, now you can draw a rectangle now on a plane. It can be on the front plane. After yes, after that, so when you choose a plane now, which is your your front plane, you draw a rectangle shape. That's a sketch. You create a sketch on that plane and you draw a shape on it. After that, you can apply a feature like extrude, revolve, extrude cut, extrude boss piece. You can show it to 15 millimeter. Then you have a 3D box. You understand? So in your SolidWorks, you will see in the sketch in the space that's provided for you to model. You're going to see wireframe, surface, and solids. So the wireframe is like a basic representation of your model. It only shows you the edges of the object. It's like a it, it depicts your model into lines. Yes, let me put it into lines. There's no surface, no volume, nothing. You see, you actually you might really use this feature. You might really use it. So moving on to surface. Surface model is like outer skin of the object is like a hollow shell. I'm moving on, and that's what we're going to be using mostly. That's what we use and what we see. It consists of volume, mass, and other physical properties. You can only simulate on a solid body, not on a wireframe or not on a surface. So now this is actually the part that differentiates a normal a that differentiates a 3D user or someone that just uses line, that just draws line on the system. Design intent is actually how you build a model and how it should reflect how the part is meant to function. So let me give you an example now. For on the screen, you have, let's say you have a flat surface and you need to drill a hole in it. The hole must actually stay perfectly centered on this plane. That's a design requirement. So let me share my screen. Let me share my screen on SolidWorks. So let me show you what I'm talking about. Come, let me share my screen on SolidWorks. Okay, now so let me show what I'm talking about here. So as I said now, design intent is not just drawing. So as you can see, I clicked on the front plane. When I clicked on the front plane, I just drew, let me just draw a rectangle as I said. Let me just draw this rectangle. Yes. And you go to the feature over here, you now extrude, let's extrude by 15 millimeter. Extrude by 15 millimeter. It is okay now. So I said something like, imagine you want to make a hole on this surface, a hole on this surface. So just making the hole alone is not actually enough. So you have to like reference it to the surrounding edges. That's actually what it actually help you in avoiding errors. So let me give you an example. Let's dimension it. So that's you can see you click on when dimensioning you click on the center of the object, you hold down the shift button, then you give it and you click on the edge you want to reference the dimension from. Let's put it as 10. 10. So let's do this again. Click on the center, uh click on the left side of the body, that's the left line. Let's also give it there. Yeah. So let's also go to extrude cuts 50 through. So as you can see now, if you see, if I was to explain this to you now, like I would like you guys to understand that if I had not actually if I had not actually referenced if I had not actually referenced this circle here to both sides of this solid body, this hole here won't still be in the circle. So let's say I expand this now. So let's exit this. Let's say I expand this now. Okay, I didn't give this dimension. Let's give this a dimension. Let's say I expand this to 400. 400. Okay, and I expand this to 300. 300. So let's exit this sketch. You will see that this hole over here still maintains this distance of 10 from the left and this distance of 10 from this line over here. If I had not given or reference this dimension from the line over here, so let me show you. You will see that this hole will actually shift. It won't be in alignment as I originally wanted it to be. So let me delete this now. So clicking on it and now deleting. Okay, yeah, deleting. Okay, so let me do something again now. Exit the sketch. Go back to my boss base. Let me increase. Let me increase it to 500. 500. Raise it. You can see now. I don't know if you guys understand what I'm trying to talk about when I speak of design intent. So now, in things like this, now you have to make sure you actually reference your dimensions by giving it the appropriate values. even if you draw a rectangle, now, yeah, you draw a rectangle, uh, you draw a rectangle here, and you know that this is exactly what you want it to be. This is that exactly how you want it to be. Whether this model over here increases or in size, in shape, or width, you just want it to be in the center of this model. You have to reference it. You have to dimension it. Reference dimension. You click on the center line here. You click on this line over here. You dimension it. Yes, you dimension it. You do the same thing for the other side. Click on this center line over here. You click on this on this line over here. You, you you dimension it. So even if I increase this, I increase the size of the yes the size or the length or the width of this model. Let me do something first. So let me extrude this. Let me extrude cost. That will be an easier explanation. As you can see. Now, let me show you something now. You know, actually, I reference this sketch of this cut extrude left and right. So let's say I increase this now. I increase this dimension. Let's say I increase this dimension to 1000. 1000, yeah. So 1000. 1000. Yes, I can see now. Our cut extrude is still in the middle. The same in the middle. If I had not actually referenced the dimension to this edge over here and this edge over here, it will actually it actually give us an error or a mistake like this hole over here. You know, I deleted the dimension that was relating to this edge or to yes to this edge of points over here. If that dimension was still here, this hole will actually be here. As you can see now, our dimension between this circle and the edge over here is okay. That's why it was able to maintain its position 10 millimeter away or 10 millimeter from the center. Okay, that's all for now. Let me share my screen to our PDF back. Okay. So I don't know whether you guys are still on this call. It's only Mosimolu that is on this call. Are you still active on this call?
Yeah, I'm active.
Okay, and I hope you have your SolidWorks open.
Yeah, I'm on my SolidWorks right now.
Okay, did you just download it or you already had it? You already had this before this training at all?
I had it before the training.
Okay, had it before the training. That means you already a normal SolidWorks user.
Just the basics, just like simple isometric.
Okay, that's the basic. Okay, that's not bad. That's not bad. Although this is just for the theoretical. This class was actually for theory to expose those that don't have knowledge, that don't have knowledge of CAD. But anyways, let's continue. Since you already have prior knowledge, but I'll have to like go through step by step for those that will request the recording, which I'm not sure might be accessible until after the whole session.
Okay.
So as I said now, the design index is actually how okay, let me continue. Design index is actually how you build your model, how it reflects what you are building. A beginner would actually measure from one edge or from one end like the hole that I actually drew from the left on the on the rectangular bus extruded bus base there. That's actually what happens when you don't reference your holes to the edges. Or yes, if you don't reference them in an orderly manner, you might just lose some work. You might just get inaccurate models. That's why we have to set the relations, especially when it comes to our dimension. So when we moving on to this parametric design now, so in parametric design now, it, it's not about lines. In SolidWorks now, everything you do has like a timestamp on it. Yes, like there are actually numbers attached to everything you do. Whether you undo, you redo, you extrude, you cut, you move front, you move back, you rotate. Everything you do has like a timestamp on it. So the parametric modeling now is how is like a history of your card, what you did. Like let me as let me just revert back to this. There's like a history now of your card. Hmm. I'm sure you understand since you're already a card user. So it's like a history of your card. Yes, okay, this let me share this. Okay, now as you can see now, this is like it stores everything you do. Some card software don't actually have this feature for you to be able to iterate back to former features that you have done. So I can actually undo this now. You see that it has gone. The more I do, you are at our by the left here, our dimension of 1000 has reduced back to 500. If I do it again, you can see that our cut extrude has reduced back, and now our cut extrude is gone. Just the sketch that is here. So let me go back to it. Here. So we also have geometrical constraints in CAD. So they're like rules that you apply to your sketch. Yes, they're like rules. Things like horizontal line. If you draw a line in SolidWorks, should it be horizontal or should it be vertical or should it be at an angle that is perpendicular? There are like relations. Yes. So it can be parallel lines, it can be centered, it can be fully constrained, it can be fixed. Every element actually has a constraint in SolidWorks. Okay, show you something like this. So let's create let me show something like this. So what I was saying. So I'm actually going through this process just for recording purpose. So this is the line now. As you can see over here now, you can see horizontal, vertical, and fixed. You can see horizontal, vertical, and fixed. So anytime you draw a line or you even draw a shape, let's cancel this. Let's say you even draw a rectangle. Draw a rectangle over here now. By default, all these are actually perpendicular to each other by default. But if as you can see it now, there's a vertical line here. This vertical line. So moving on, you also have this is horizontal. So by default, they are all perpendicular to each other. But if I was to delete this now, yes, if I was to, wait, so let me show you something now. Let's say I want to give this an angle now. By default, I can't change this. Yes, so let me cancel now because I can't change it because of by default they are perpendicular to each other because they already have a dimension of horizontal and vertical here. But let me delete this this vertical component over here now. Let me delete it. So just delete. So as you can see, I've deleted the horizontal relation that's attached to this line now, and I then perform an angle dimension. You can see that it gave me access to modify. So let me just put 120. It gave me access to modify. But the remaining parts now, like this one, you can see their relations are still there, horizontal. Even this. So even if I try to perform an angle dimension, an angle dimension on this, an angle dimension on this, by default it is 90, and I can't change this at all. I can't change it at all. So I'll just this make this dimension by driven means I should just leave it that way. I can't change it. So that's all. So I think I should have shared the slide to Princess, so you guys should have reviewed it from that side. But that doesn't matter. Okay. So I said the constraint actually what are like rules that guide you in modeling. Okay. I'll share this slide so you guys can read it through. So your feature tree. So the feature tree is it shows the history. Yes, it shows the history of a parametric model. Like this now, let's imagine the shape that I drew was part one. I know in part one for a model you must have a sketch, and a sketch it must have a sketch, and a sketch must have a feature, and this feature is a boss extrude, and on that same boss extrude, I performed a a a sketch on it, and that sketch I applied a feature of cut extrude. I don't know if you're getting me. So that's just how this feature tree is. This feature tree is okay. So that's all on what I wanted to present for everybody. And I think Princess is actually noting attendance for this class. So we've covered CAD, 2D, 3D, XYZ, front, top, and standard views, solid surface, design text, and SolidWorks. That's all for now. Although I actually moved on to the CAD itself. So by next class, we'll be touching SolidWorks itself. And if actually people were on this call, I would have moved on. I would have moved on with the CAD itself. But for yeah. So let me just continue. Control A and delete everything. Delete everything. So I'm deleting it now. Is it okay? So let me delete all this again. Okay. Now everything is blank now. So just to recap everything I said on the slide, this is our feature tree. And our feature tree contains the front plane. So you can make it normal too. Yes, that's just click once you click on the front plane, you press normal, you click on normal too. So let me make it visible so it is showing. So the top plane, as you can see, the top plane, okay, the right plane, I'm making it visible. And this is the origin. Origin is okay, I think the origin is visible. So now moving on to the orient. So I know I explained to you guys the front view, the top view, and the other views, as I said, the custom views at the left and the bottom. So let's move to the isometric view, which I share to you guys as an overview of the whole card itself. This is the overview. So as I said, to create an object, you click on the plane, the top plane. I clicked on it. You click on the sketch. You draw, let's say, a circle. Drop down a circle. You can start anywhere. Or you can start from the origin. After that, you apply a feature. The feature is actually what makes it 3D. Extrude, enter. So as you can see now, this is the top plane. This, although because it's a circle, you can actually name any. You can start the front plane and the right plane are intertwined in it. But if this was a rectangle, you'll be able to depict the side and the front plane easily. So let's move on to I told you about the display orientation. As I can say, this is the wireframe I talked about. The wireframe has no volume, nothing. The wireframe has no volume. It's just lines. Okay. You can also make the hidden lines visible. It just makes it more darker. Then this is solid body now. The solid body is actually what we are going to be using. So that this will be all for now. So I'd like you guys to just go through everything, starting from the just play around with it because to actually understand card is by what you do personally. Play around everything that is here. By next class, we're going to focus more on SolidWorks itself, and this training will be more of practical than theory. Yes, I'm going to actually be using every single thing you're seeing here, every single thing. Also, although I don't know how you guys system might carry simulations. Simulations. Let me show you. Simulation is not here. Yeah, this is what I'm looking for. Simulations, something like this. Yeah, the simulations. This is simulation parts. This actually might come in after the whole session because of what you actually need is you guys to understand the card first. Okay, that's all for now. So stop sharing. So good night. I don't know your name. Don't be annoyed. Ajit Cafe.
It's Ajishafe Mosimi Lolo. Well, you can just call me Mo. Mo. No, it's fine.
Okay, more. Okay, that's all. So thank you
Yeah.
for staying throughout the call. And currently next class, I might not explain or do things technically. I'll just move on with the how I put it, move on with the SolidWorks itself. Okay, so
No
wait first, let
problem.
me end the recording over here. Okay, no problem. Good night.
No.
Okay, good night. Okay.